Hello, you made it back. Good. Welcome back to Math with Sensei Brian. I'm Sensei Brian McWashington, your math sensei, your math coach, your math homie, your math partner, whatever you want to call me. Anyway, on a personal note, I'd really like to thank everyone on Facebook, everyone on YouTube, and everyone everywhere that's been liking, subscribing, and sharing my videos, especially the sharing. That really encourages me to keep going because in this day and time, everybody needs a little help, and a little bit of kindness goes a long way. This is something we've had. Numbers have been here long before us, and they'll be here long after us, so we might as well learn to get along with them, right? Good. Let's get started in my fifth installation of Math with Sensei Brian. Today's topic, decimals. What are decimals? Decimals are a fractional part of a whole number. Remember whole numbers? 0, 1, 2, 3. Whole numbers. Whereas counting numbers start from 1 and on and on. Well, what's the difference? When you're dealing with whole numbers, you're dealing with whole quantities of something. Pies, cakes, headphones, cars, houses, shoes, anything, that's an entire quantity of something. Whereas counting, you could be counting parts of something. So that's the difference between the two. Now, you say, well, what truly, that's the definition, but let's see what decimals. Well, really, fractions and decimals are the same thing before I go any further. It's just that fractions are an easier way of writing a decimal. Case in point. We have 4 whole pies here. 4, quantity. Now, we have what? 3 whole pies and part of a pie, or half of them. So you would naturally say 3 and a half. Now, if we wrote this number as a decimal, it would look like this. Well, I should use the arrow because it's really equal. Well, how are these two the same? Simple. Remember I told you whenever you see this, this is actually a division problem. So how you get this, just a quick thing, to be this, you do this. Well, you really can't do that, so you got to do this. 2 goes into 10. 5 times 10. What do you know? Right? There it is. So, give me 1 second and I'm going to show you something. Yeah. Now, this number, those of us that have been around a while, 5.0. Well, those of us that's been around a little bit longer, remember the Mustang 5.0. Yeah, I know it's a little funky, but so what? It's a car we had back in the 80s and 90s, and there's a very, very fast engine, 5.0. But really, what's the difference between this number and this number? Well, this little dot right here, that's the decimal point. So to show you what I mean, this is actually 10 times more than that. Because if you want to write it as a decimal, you'd write it this way. So I'm going to show you exactly what the real difference between these two is and what roles decimals truly play in what we do. Here we go. All right then. So we have these numbers on the board. You recognize 1, 10, 100, and 1,000. Remember when we did our video on exponents? This is where they come in. Any number that has a 0 as a power, that number is 1. Any number, it can be 85, 340, 6 million. To the 0 power, it always equals 1. Then there's 10. 10 to the first power. 10 times itself 1 time. 10. Hundreds, or 10 to the second power. But guess what? In this case, there's 2 zeros, second power. The power of 10, that's kind of easy. So really, if you add a 0 to any number, you've multiplied it by 10, as you see here. 10 to the second power. And 1,000 is 10 to the third power. You see 3 zeros. That works for the number of 10. But notice these little funky terms on here. Deca, hecto, kilo. Those are actually Latin terms, right? Deca means 10, as in decade. Hecto means 100. Kilo, you recognize kilo. Kilograms, kilometers, right? 1,000. But then you got these numbers on the other side, right? Here's one written as a decimal, 1.0. Still 10 to the 0 power. But what is this? 0.1. And why is there a TH on the end of it, excuse me. Put that on the blooper reel. Anyway, remember decimals are a fractional part of a number. So the TH in these numbers represent that, right? And to what degree it is. So it's 10 to the negative 1. You have 10. I'm going to say this. No one ever really said this to me. I just figured it out on my own. It's 10 written backwards. So to the 10th, right? 10 to the negative 1. Well, now you got hundredth. There's that TH again, right? But now you write 100 backwards. There's still 2 zeros, but it's 2 going the other way. Remember, like we said, negative numbers are counting the other way on the number line. See how all this is going to tie together. That's why we do it like this. I want everything to tie together, okay? And then you have thousandth. Well, guess what? 10 to the negative 3. You wrote 1,000 the other way. There's 3 zeros in 1,000. There's 3 zeros in 1,000th if you put it here. Easy way to remember that for you. But now you have these little Latin words again. Prefixes or come before the word. Deci. 1/10. Dime. How many dimes do it take to make $1? 10. Centi. You should recognize this, right? Centimeter. Centiliter. Centigram. It takes 100 of these to make one of these, or 10 to make one of these, and 10 of these to make one of these. Your standard numbering system. Ones, tens, hundreds, thousands. It works the same the other way. And the same with thousand. Milli. Milliliters, millimeters, milligrams. It takes 1,000 of these to equal 1 whole of these. So decimals represent the actual amount of the fractional amount. Remember, fractions can be an approximation, as we'll see as we get further on into my next chapter of fractions, whereas you're just kind of making it easy to see what it is with a fraction, but with a decimal it shows you exactly what it is. Okay? So I'm going to wipe the board clean and be back in a second. Looks clean to me. Okay. Let's get into this. Oh, I'm going to write a fractional number. I mean a decimal number. Let's say 34.61. Okay? Remember we had the ones place. We had the tens place. So that's 3 tens and 1 4, or 34. Now you have 10 in the tenths place and 1 in the hundredths place. So that's 34 and 61 100ths. But an easy way for us to say that as we do is 34.61. Okay? So that's actually what a decimal is. You have 34 whole numbers and 61 100ths of a whole number is what you're actually saying when you say decimals. Or 34.61, but I'm going to make it look a little easier for you. Now you say $34.61, but it's 61 pennies. You need X amount, which is probably what, 39, to get to a whole number. You're still using decimals whenever you use money. The only difference is with money, you only go 2 places back. When there's a gazillion, which ain't a real number, but just means something, a gazillion places behind there. Okay? So, I'm going to take this away from you. Now, supposing I want to add another decimal number to it. Let's try 8.3. How do we add this? You can't really add straight up and down. I'm going to show you a secret. Okay. Where's the whole number placed in the bottom number? If you said 8, you got it. Where's the whole number placed in the top number? If you said 4, you got it. So, this is what we do when we add. Add this to the blooper reel. I just dropped my pen. Add this to the blooper reel. Now, will you say, gee, Sensei, it just looks plain out empty. Well, it's not empty no more, is it? Okay. All I did and all you will do in the future is whenever you add or subtract decimals, this is an addition problem. Let's make this clear. You will line the decimals up. And if you got more spaces on one than the other, you just add zeros. Doesn't matter because it doesn't change the value of this. I can add 30 zeros and it's still going to be 8.3. But to make it look better and easier to work with, we add whatever we need, okay? So just add 1, 9, 12, 4. Now, in these, you bring this decimal point straight down. And you can use your calculator, computer, and you'll see it, okay? All we did was just line up the decimals, okay? Line them up. We added a 0 where we needed it and add it. Well, gee, what about subtracting? You do the same thing. If I was to subtract this number, let's subtract it, right? Let's go 1, 3, 6, 2. You do the exact same thing. All you did now was subtract. The numbers line up, the decimals line up. Not bad, huh? Okay. Let's try another one. Let's say, 34.12 plus 63.8943.7. All right? Well, gee, how do we do that? What did we say we do earlier, right? Because this is an addition problem, doesn't matter which order this is in. Commutative property, right? You can switch these numbers around. It's addition. Watch this. Line the decimals up. Now, remember you have more numbers on the top number. All we doing is adding the zeros. Guess what, my friends? Added or subtracted. I'm going to add it because it's easy. There's 437, right? 11, 10, 11, 69. There you go. And it's that simple. Okay? This, as far as addition and subtraction, is extremely simple. Okay? If you want to subtract it, do the subtraction. In fact, you know what? I'll do it with you. What kind of teacher would I be if I said do it on your own and you just learning this? So let's subtract this, right? Here's 7, 3, 4, 7, 7, 6, 2. Okay? Same thing. We're going to do something a little different now. Let's try multiplying. 2.5 times, let's say 8. Okay. Well, how do we do this? Move the 8 down here so you know what it is. Can I write 8.0? Sure, but it's a waste of time because now you got to factor in that 0, right? You don't need to do that. If it's a solo number, do it like a normal problem. 25 times 4 is 100. 25 times 8 is 200. Right? Or 5 times 8 is 40. 16 and 4 is 20. There you go. 200. When you get good in math, certain things will click inside your head. Patterns you'll start to notice. Hopefully, as we go along, you'll start noticing patterns and be able to do things a lot easier. Okay. On this note, how many decimal places are there? 1. Bring it down. There you go. It's that simple. Not bad, huh? I'm going to keep that same 2.5, but this time I'm going to multiply by, let's say, 6.8. Okay? Again, you can commute these. You can put this under here, which we'll do, because it doesn't matter. It's multiplication. The commutative property works in multiplication as well as addition, remember? So let's multiply. It's a straight problem. There's 40. 6 times 5 is 30, and 4 is 34. Bring down a 0. 16, 13. Add it up. 0, 10, 7, 1. Now, how many numbers do we have behind a decimal point? This is considered one decimal point, not 2. So how many numbers are behind it? You have one number here, one number here. So guess what? Now you have two numbers. There you go. Two places, two places. Always from the left. Okay? Excuse me, always from the right. I don't know my right from my left. 52 years old and still make that mistake. Anyway, always from your right to your left. Okay? Division. Okay, let's write this in long form. Now, because there's no decimal point out here, we don't have to move this one. We just bring it up, right? So 3 goes into 6 twice. 2 times 3 is 6. Now you bring this 1 down. Obviously, we know 3 does not go into 1. It goes into 0 times. Add another 0. This is not going to matter how many zeros you add. 3 goes into 10 3 times. This is 9. 1. You're going to see this again. Whenever you see this line over the top of a number, that means it repeats. Okay? That's a repeating number. That 3 is going to repeat 350,000 years after we're gone. That 3 will still be going. Okay? But here's your answer. Okay? 3 into 6.1. Well, it goes into 6, but you have the 1. 3 doesn't go into 1, but it goes into 10. Right? And on and on and on. We're just going to stop there. I'm going to give you one more. Let's do this. Okay. 8.4 divided by 2.2. So this was going to be a little bit different. Right? Ooh, that 2 looked terrible. My mama always said I couldn't write. Okay, now you have a number with these. The rule is, when you see that, you move this one place here, and you move this one place here. Add a 0. Now, 22 goes into 84 how many times? 3. That's 66. 14 minus 6 is 8. 0. It does it again. Okay, as you see, this is going to be a long number. I'll go ahead on and do this one time. This number is going to go on for a while, but you see what I mean. That's what I say. A decimal is an actual, it's going to give you an actual number, whereas a fraction is going to give you, I want to say, more like an agreed upon number. And you'll see what I mean in my next chapter when it comes to fractions. Okay? But as you can see, the point being, whenever you have a decimal point on this number, and there's one on here, however places you need to move this over to make it whole, you move it over here to make it whole. Always to the right. Always to the right. That's where we make our mistake. A lot of times when we make our mistakes, we put the decimal point in the wrong place. Meaning you can be off by a factor of 10 or a factor of negative 10. Okay? So be careful. Be careful when it comes to decimals. It's so important. So many people, when it comes to math tests, make the mistake when it comes to decimal placement. Like if I say, write $386.20 out of those numbers. Where would you put the decimal point? Would it be here, 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 or here? Looking at it may be a little funny, but if I did this and told you to do $386.20, where would you put that decimal? Probably right here. Well, gee, Sensei, it says 0.2. Make feel better? There you go. Whenever you deal with money, you deal with decimals. But you only deal with two places. The tenths and the hundreds, or the dimes and the pennies. Well, they don't make tenths of a penny. Well, they used to make half pennies, but they don't anymore. It's got too confusing for people. So we just agreed upon that. So, decimals play an important role. I mean, I tell you what, if you brought home a paycheck that looked like this, right? If I brought home a paycheck like this after working 5 days, I'd be a little bit upset, right? But if you bring home a paycheck looking like this, oh, I think you'd be a whole lot happier, wouldn't you? Because now you made 100 times more. And isn't that amazing? Instead of making $143.56.2, you made $14,356.20. The importance of decimals. That's not. I can't stress it enough. Money is probably the biggest thing you're going to use this for. Okay? You certainly don't want to be short with your change. You do not. You do not. You do not. You thinking you're going on a date and you got all this money, you come up way short, she's going to look at you funny. So be careful. Always be aware of decimal placement. Always be aware of decimal placement. I hope this helps you out. This is a topic that can take a long time. I just try to give you an overall brief of it. Please let me know if I need to cover some more, and I can always redo this video in the future. I can't stress decimals enough. I just can't, because you can be off by 1 decimal point and you're trying to get somewhere, you can be 10 miles off. Well, imagine if they did that going to the moon. You'd miss the moon by maybe 30,000 miles just because of being off 1 decimal point. Please be aware of where you place your decimal points. God bless you. Be kind to one another. I always end the video by saying be kind to one another, because all it takes is one person to be good to you, or you to be good to one person, and it'll change their life. I've seen it. Please be kind to one another. Love one another. God bless you. Until the next time, Sensei Brian out.